Hi, my name is Tom Van Land, the founder and CEO of CloudCalc. Some of you may remember me as the longtime CEO of CoAid, the developers of the Caesar 2 Pipe Stress program. I am pleased to tell you that with CloudCalc, I am now back in the world of pipe stress. Today, I'm going to give you a quick overview of CloudCalc's new pipe stress analysis product. I will show you how easy it is to model and analyze a piping system using CloudCalc. In the course of doing so, I will point out some of the powerful capabilities I have long wanted to bring to the world of engineering software. These capabilities, such as device independence, collaboration, and support for mobile devices, make our product unique when compared to PC-based engineering software that you may have used previously. One advantage of CloudCalc is that you can access it along with all of your models from just about anywhere you may be, using just about any browser on just about any device, including PCs, Macs, tablets, or even smartphones. You can sign in within seconds from any computer. If you don't yet have an account, you can get licensed in under a minute. And with CloudCalc, you are not committed to a perpetual license. The product may be licensed for durations of 1 month or more to precisely match the expected duration of your project workload. Just select your product, as pipe stress, and click and go. Once in CloudCalc, you see that the product's intuitive interface operates similarly to what you've come to expect or want with other PC-based software. CloudCalc is flexible in that you may build or edit your model by typing in data here on the data entry sheet. Or you may elect to model your system graphically using the mouse, icons, hotkeys, and commands picked from context menus. And of course, you can use any combination of these two methods. CloudCalc's input menu offers a number of screens for defining or reviewing the model data. You can enter descriptive information or notes about your job. Job parameters allows you to select the effective code along with other job-wide information. Modeling takes you to the main data entry screen. List view lets you review the elements in context of each other. There are also plenty of other screens for entering other data, such as piping loads and load cases. CloudCalc analyzes piping systems for statically applied loads, applying the rules and analyzing the resulting stresses against the requirements of the ASME B31.1 and B31.3 piping codes. In addition to stresses, the static results include piping displacements, restraint and nozzle reactions, spring hanger design, and piping internal forces and moments. Dynamically, the program performs modal extraction, calculating natural frequencies and animating mode shapes. Cloud-based products such as CloudCalc provide certain advantages that PC-based programs will never be able to match. One of those benefits is that we support intra-project collaboration, making it easy to share your models with colleagues, even if they do not yet have a license of CloudCalc. Imagine how much more efficiently your team will work once all project stakeholders have easy access to the models and calculations. In addition to letting you build models from scratch, we also provide interfaces with other related products. CloudCalc can import PCF files, a file format which is supported by most popular piping design products. CloudCalc can also both import and export Caesar 2 neutral files, which provides a two-way link with many other pipe stress programs. Our online database also includes properties such as code allowables, coefficients of expansion, and modulus of elasticity for over 1,000 materials, as well as dimensions for 600 plus pipe sizes and schedules. And of course, our program has extensive help facilities, including online documentation, a tutorial, and a video library that will make you an expert quickly. And finally, the frequent program updates are applied automatically without you ever having to wait for the intervention of your IT staff. You can rest assured that your software is up to date, always. Okay, let's see how easy it is to build and analyze a piping model. We'll first create a new model, give it a name, call it new. There are several ways to build a model from scratch in CloudCalc. We can type in the data screen by screen on this data entry screen. For example, the dimensions, the pipe size and schedule, add a bend. Let's add a restraint. CloudCalc supports a wide range of types, many with nonlinear capabilities such as frictions, gaps, and one-way functionality. We can also add operating conditions and other loadings. In this case, we can add up to 9 different temperatures, 10 different pressures, as well as many different fluid content densities. Hit the next link or page down key. You'll register the element and proceed on to the next empty data sheet. We continue to add the next element, and a third. We will make a valve. Alternatively, you may elect to build your model graphically, a process that may be more intuitive and even quicker. Clicking the CloudCalc logo hides the data entry screen to provide more graphic modeling space. Data entry is facilitated by using the Quick Entry screen. Properties can be edited by selecting elements or nodes and then choosing from a full range of editing commands available from the context menu. While building your model in CloudCalc, don't worry about making mistakes, because the mistakes are easy to fix. The program offers unlimited undo and unlimited redo. Anytime you want to return to the datasheet form of modeling, it's easy. Just click the CloudCalc logo when you want to reveal the datasheet. Click it again to give yourself more graphic space. In addition to building a model from scratch, you may elect to import the piping model directly from your plant design program, most of which support the PCF intermediate file format. Simply go to Tools, Interface, PCF Import, and then select one or more PCF files. In this case, we will be importing from Autodesk Plant 3D. We can pick one or multiple PCF files depending on how many make up the system that we want to model. In our case, we'll import 3 of these. Almost always, when importing PCF files, some data will be missing or ambiguous, forcing CloudCalc to make some assumptions while building the model. All of those assumptions get highlighted here through warnings to the user, letting you know which information has to be verified, added, or corrected. For example, here are a lot of messages indicating how piping end connections have been treated, typically connections to equipment nozzles or larger pipelines. These are modeled as currently 0, but potentially non-zero imposed displacements. We see that in this case, the system geometry, the individual element properties, such as pipe diameter and schedule, and pipe supports have come across accurately. Element types, such as rigids, bends, expansion joints, and so forth, have also imported correctly. This file includes some valve and flange weights. Here we see that the import of the T-type, a welding T, was also successful. Every PCF file varies in how much and what type of data it has available. They may include wall thickness, material type, temperatures, pressures, fluid, and/or insulation data. At best, the model may be fully ready for analysis. In our case, you see that the operating loads were not imported, so we will have to add those manually. The easiest way to do this is via a group select, followed by a graphic editing command. We will first select all of the piping elements and then use the context menu to define the fluid contents, a specific gravity of 1.0 throughout the system. The 3 individual lines each have different operating conditions, so they need to be selected individually. We could use a window select, but the easiest way to select them is via line number. In this case, the line numbers were assigned during the PCF import. The first is 1002. We can apply a temperature of 200 degrees and the pressure of 3,000 kPa. Next is line number 1005. This line has a temperature of 225 and a pressure of 2,400. And finally, we have line number 2525. Which has a temperature of 300 degrees and a pressure of 3,400 kPa. It's probably a good idea to graphically verify the imposed loadings. First, remember all of those pipe end connections that got modeled as zero displacements? Here they are, in this case acting as anchors from an analytical point of view. Temperature loads are color-coded with the key in the upper left. We see that they are different for each line, as are the pressure loads, different for each line. Meanwhile, the fluid is the same throughout. Okay, now it is time to analyze the pipe. First, we need to set up the load cases, which will define which load components are included, what stress type they should be analyzed for, as well as some other parameters. Load cases may be set up manually, or we can get CloudCalc to do it by clicking this Initialize Load Cases button. Clicking this button will get CloudCalc to look at all of the load types that have been defined, looking at the piping code and whether spring hangers are present, and then build the appropriate load cases. For example, here we get 2 load cases in one combination case. The first case contains the pipe self-weight, fluid weight, pressure, and temperature, and has stresses calculated and evaluated as operating stresses. The second load only includes the primary loads, that is the pipe and fluid weight and the pressure, and is evaluated against the rules for sustained stresses. Then we have a load combination, the algebraic difference between the hot operating and the cold sustained case, which is then evaluated according to the rules for expansion stresses. Now that we have the load cases set up, we can run the analysis. After a few seconds, the results of load case 1 appear. While looking at the displacement report, this blue line appears on the graphic model, indicating the displaced shape for that load case. Even though it has been scaled up, the displacements do seem to be excessive. As we see here in the report, they exceed 450 millimeters. That's one issue that will have to be fixed. We'll have to find a way to reduce those displacements. Most likely, we will have to add support to the long run of unsupported horizontal pipe. Next, let's take a look at the restraint loads during the operating case. We see that there is no load acting on the plus Y support at node 170. This means that it is lifting off during the operating case, which is not a good design practice. That is the second issue that we will have to resolve. We will have to change the support type to a support that can permit the thermal movement while still supporting the pipe. Next, we take a look at the sustained case, and we see that it fails the stress check. Switching to the code compliance report, we can check each individual element for its compliance level and whether it passes or fails. While looking at the code compliance report, we get a color-coded code compliance graphic. We see that the piping fails due to stress criteria during the sustain case in these areas which are marked in red. That is the third issue we will have to fix. Hopefully adding the supports, as we were intending to do to fix the first problem, will also solve this one. Now, let's look at the expansion case. We see again there are additional overstresses. This time focused on this area here. This is due to thermal expansion and can be best solved by adding flexibility through an expansion loop. So that's 4 failure areas that we need to solve. So let's see how we can do that with CloudCalc. We need to add a couple of supports to these 2 horizontal runs of pipe. The easier way to do that is to select each segment and then break them using the context menu. We can break this pipe into 4 equal segments, like so, which will provide new nodes for 3 supports. Now we select the other pipe and break it into 3 equal segments to add 2 supports. We can make it easier to work in this area if we hide the pipes that we are not dealing with. So let's select this line number 1002 and then use the context menu to hide all unselected elements. Now let's turn on the node so we can see where the breaks were made. Next, we select the nodal locations where we want to add the restraints, these 5, and use the context menu to do so. We can add vertical restraints, which are type Y. This should take care of 2 issues, the excessive displacement in the operating case and the overstress in the sustain case. Next, we want to take care of the support that lifts off of node 170. We need something which can continue supporting the pipe while accommodating the vertical thermal growth of the 2 risers, such as a spring hanger. So first, we select the node and delete the restraint. Next, we can use the context menu to add a spring hanger in that location. CloudCalc includes the hanger catalogs of a number of the more popular spring hanger manufacturers. You can specify any parameters that you need to as per the hanger design requirements. Okay, so that should take care of the third problem, the liftoff of the support. Now we can tackle the expansion overstress. Most likely we will need to add flexibility by placing an expansion loop in this segment here. The easiest way to build that loop is again to select an option from the context menu. In this case, the automatic loop builder. The loop builder allows you to parametrically build either a 1-dimensional or 2-dimensional loop in any orientation. Let's try here an 800 millimeter loop in 1 dimension. Okay, so that should take care of the fourth and last problem, the expansion overstress. Let's reanalyze and see how things are now. So that's back to the static load cases. Because we have added a spring that needs to be designed, we will need to add 2 initial load cases at the beginning of the load case set. The Initialize Load Cases button can take care of that for us. If we click here, we see added up front the restrained weight and the free thermal load cases. The information from these 2 cases is used to select the spring hanger, which is then used in all subsequent load cases. So let's analyze again. After a few seconds, here are the results. There's a new report for spring hanger design. It shows which model and size spring hanger was selected, as well as the cold load and the hot load settings. Now let's see if these problems have been resolved. The maximum displacements in the operating case have now been reduced to about 30 millimeters down and 12 millimeters up. That's a great improvement. Looking at the restraint loads in the operating case, we see that none have lifted off or are otherwise inactive. So that's issue number 2 dealt with. Now for the code compliance reports. Here's the sustained case. Everything is green, meaning it passes. And finally, the expansion case. Everything passes there as well. So we have fixed the 4 problems that we identified from the original run. Of course, in real life, you would have to verify that all the displacements and restraint nozzle loads are within their allowables, but on the face of things, this appears to be an adequate design for this piping system. So we may want to print out the results of the calculation for review or for release for construction. CloudCalc lets you output the results to a PDF for printing or to Excel for further processing by clicking these links here. If you only want to output a subset of the total system, you can click this box and you will only get results for whatever elements are currently selected. The PDF report automatically generates a cover page, an input echo, all of the reports for all of the load cases, plus a table of contents. Remember, if the report ever gets too wordy, this one here is 111 pages, you can reduce it to a subset by selecting a limited number of elements and clicking the checkbox we saw earlier. Finally, there's one more thing that you might want to do. If your company or your client normally uses a pipe stress program that is compatible with Caesar 2 neutral files, you might want to export it to Caesar 2 for final processing and archiving. In fact, since CloudCalc both imports and exports Caesar 2 neutral files, models can be passed back and forth between CloudCalc and whatever Caesar 2 equivalent software you may be using now. In this way, CloudCalc can fit near seamlessly into your current existing design process whenever you might need to add some temporary licenses. Now, what else might we want to do? Well, I told you that one of the big advantages of being on the cloud is that CloudCalc promotes collaboration. What does that mean? It means that you can share your model and calculations with others on your project team. Simply go into the collaboration option, select whichever colleagues have a need to know, let's say the site engineer, for example, and share the model with them on a view-only basis. Okay, so now we, as the home office engineer, are done here. Let's move on to the job site, where we can further explore the benefits of cloud-based software. We can get a better idea of how collaboration can benefit, especially when it works in tandem with support for mobile devices. Let's say that a problem has arisen during construction of this particular piping system, and the site engineer is asked to weigh in on some potential changes. With traditional PC-based software, the site engineer has rarely had access to the original calculation and thus has had to make decisions based solely on experience or gut feel. In other words, not based on actual information. Well, that is about to change. The site engineer can now make fully informed decisions using whatever device is convenient, such as a computer, a tablet, or a smartphone. In this case, he or she may decide to sign into CloudCalc via an iPad. When accessed on a mobile device, CloudCalc presents a custom layout tailored to that device. For example, on a tablet, due to the smaller screen, we eliminate the shared window and rather allow you to toggle between the graphics in the data entry screen. Likewise, since there is no mouse, a lot of the graphic editing commands are done using the bottom row of icons or standard gestures such as double tap for selection, pinch to zoom, tap and drag, etc. The context menu is not active since there is no mouse and therefore no mouse button, but all graphic editing commands are accessible from this graphic editing menu. But aside from these nuances, the experience is nearly the same. and just about anything you can do on the computer, you can do on a mobile device. So let's see how we access that piping model in order to resolve any job site questions. Click File Open. You see that model New is not there. However, checking this box shows Shared Jobs. There are two of those. We can open Job New, but since it is view only, we will be unable to make any changes to it. Only review the model and the calculation. If we wish to make changes, we will have to save a version under our own name. So let's do that. We can also call it New or anything else. Okay, so now this one is ours to modify as we wish. Let's start with a quick analysis to get an idea of the design condition of this system. Okay, here are the results. The spring hanger report, code compliance, everything passes, as we already knew. So let's say that a construction problem has arisen in the vicinity of this loop. Maybe the 800 millimeter loop creates an unexpected interference and the pipe fitters are asking whether it can be shortened, maybe to 600 millimeters. In this case, rather than relying solely upon a gut feel or spending the time to contact the office engineer, you can actually make an informed what-if decision in no time at all. Simply grab the tangent intersection points and move them over the requested 200 millimeters to shrink the loop. Then we can run the analysis again. Since it runs on the cloud, the analysis is just as fast on a tablet or a phone as on a computer. Now here are the results. Showing that the proposed configuration for the piping system still passes a code stress compliance check. So an informed decision can be made immediately, on the spot. Time is money, and knowledge is power. So let's review the benefits of CloudCalc. It's easy to use and easy to learn. It is accessible from anywhere, your office, your client's office, your home, the job site, or while you're away on a business trip. It is always up to date, requiring no installation or support from your IT department. It has powerful and flexible modeling and analysis capabilities. It promotes collaboration by enabling sharing among the project team. It supports mobile devices to bring informed solutions anywhere. And there are no perpetual licenses, but licenses that fit your and your company's workload. And there is a good chance that CloudCalc can be added to your project in a complementary manner without necessitating changes to your current procedures. So why not go over now to www.cloudcalc.com and check out the program for yourself. Sign up now and you will get a 1-month evaluation free. Thank you for your time. Thank you for your interest in CloudCalc. I hope you like what you've seen.